and it's very difficult to keep a surface hotter than that. In fact, an object at the distance of 3I Atlas from the sun could only be 20 times cooler than the sun, so it should be redder.
It began, as many modern mysteries do. Harvard astrophysicist Avi Loeb, the man who once suggested that Oumuamua might be alien technology, appeared on Joe Rogan's show and shared his insights about 3I Atlas. 3I Atlas didn't scare anyone, Joe Rogan included, until Loeb shared what he thought it really is. Hurtling through the solar system at more than 245,000 kilometers per hour, 3I Atlas might not be just another rock from the stars, but a relic, a probe, a silent messenger from a distant civilization. How plausible is this? Well, let's find out. The arrival of 3I Atlas. On the evening of July 1st, 2025, a faint streak of light appeared in the southern skies over Chile. The detection came from one of the 4 telescopes belonging to the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a survey designed to spot potentially hazardous asteroids before they approach Earth. This particular telescope, situated at the Rio Hurtado Observatory in northern Chile, was scanning its usual patch of sky when its automated system flagged an object moving faster than expected. Within hours, astronomers at the University of Hawaii's Institute for Astronomy, which manages the ATLAS network, verified the find and began calculations to determine its orbit. What they discovered would soon ripple through the scientific community. The object, later designated 3I Atlas, was not bound by the sun's gravity. Its orbit was hyperbolic. This meant it had come from beyond the solar system. This classification made 3I Atlas the third confirmed interstellar object ever observed passing through our cosmic neighborhood. The first, 1I Oumuamua, had been spotted in 2017 racing past the sun on an equally unbound trajectory, followed by 2I Borisov in 2019. Unlike asteroids or comets that loop endlessly around our star, interstellar objects are visitors. These foreign bodies are flung by gravitational encounters in other star systems. They are foreign, perhaps even alien in origin. Well, at least that's what Avi Loeb says. Initial orbit solutions calculated by the Minor Planet Center confirmed the hyperbolic eccentricity of 3I Atlas, which was above 1. This meant that the object will enter and leave the solar system only once. Its inbound velocity relative to the sun was measured at about 60 kilometers per second, or roughly 216,000 kilometers per hour, placing it among the fastest natural objects ever tracked. At that speed, it could cross the distance from Earth to the Moon in just over an hour. Its incoming direction traced back toward the constellation Serpens, suggesting it had wandered through interstellar space for perhaps millions of years before being perturbed onto a path intersecting our own. Astronomers mobilized quickly. Observatories across the world were alerted. Gemini South in Chile, Subaru in Hawaii, the European Southern Observatory's Very Large Telescope in Paranal, and NASA's Hubble Space Telescope in orbit. Each aimed its instruments toward the newcomer. Within weeks, new details emerged. Unlike Oumuamua, which showed no visible coma, 3I Atlas was clearly active. Even at a distance of more than 400 million kilometers from the sun, it displayed a bright halo of vaporizing ices and dust. This coma, several tens of thousands of kilometers wide, hinted that the object contained volatile materials similar to those found in solar system comets. A faint tail extended behind it, pushed outward by solar radiation and the solar wind, confirming ongoing outgassing. By late July, the Hubble Space Telescope had resolved the coma's structure and brightness variations. The nucleus itself appeared small, perhaps less than 5.5 kilometers in diameter, comparable to known comets such as 67P Churyumov-Gerasimenko, but the surrounding atmosphere of dust and gas was unusually extensive for an object so distant from the sun. The Gemini South Telescope followed with spectroscopic observations, detecting emission lines associated with carbon dioxide and water vapor. These early measurements intrigued scientists. The ratio of carbon dioxide to water appeared to be far higher than in typical comets. In August 2025, the James Webb Space Telescope turned its powerful infrared instruments toward 3I Atlas, using its near-infrared spectrograph, or NIRSPEC, and mid-infrared instrument, or MIRI. The resulting spectra confirmed the earlier ground-based findings. The carbon dioxide to water ratio was close to 8:1, an order of magnitude above what is usually seen in solar system comets. This suggested that 3I Atlas formed in a region much colder than the Sun's cometary nursery, possibly near the outer edge of a distant protoplanetary disk where carbon dioxide freezes easily but water remains locked in rockier compounds. Some astronomers propose that its birthplace might have been a low metallicity star system, one older and poorer in heavy elements than ours. As the data poured in, the object's path was refined. 3I Atlas was on course to reach its perihelion, or the closest point to the Sun, on October 30th, 2025, at a distance of roughly 1.4 astronomical units, or about 210 million kilometers. Even at that closest approach, it would remain well outside the orbit of Earth, and its minimum distance from our planet was projected at around 1.8 astronomical units, roughly 270 million kilometers. There was never any possibility of impact, but the geometry of its orbit made it accessible to nearly every major telescope in the southern hemisphere during its approach. Observers tracked its increasing brightness and the growth of its tail, which lengthened dramatically as sunlight intensified the rate of sublimation from its surface. Public interest quickly followed. The discovery of a body originating from another star system captured global imagination. Newspapers and online outlets described it as a visitor from another world and a messenger from the stars. Planetariums and space agencies organized live streams showing its predicted position in the sky. Amateur astronomers, armed with backyard telescopes, prepared to glimpse what professionals called a once-in-a-lifetime event. The Atlas team released continuous updates, plotting its motion against familiar constellations, and space agencies published simulated trajectories showing how it would loop briefly around the Sun before heading back into the depths of interstellar space. Within scientific circles, excitement was tempered by urgency. Because interstellar objects travel at such immense speeds, the observational window is short, months rather than years. After passing perihelion, 3I Atlas would fade rapidly, its gases freezing again as it receded from sunlight. To capture every possible dataset, international collaborations were formed linking observatories from Hawaii to the Canary Islands and South Africa. The goal was to measure its brightness, polarization, and gas production rate across wavelengths, from ultraviolet to radio. These coordinated efforts would provide a chemical fingerprint of material forged around another star. By September 2025, researchers had begun publishing early analyses. One team measured a faint bluish-green hue in its coma, characteristic of diatomic carbon emissions, but with intensity ratios distinct from solar system analogues. Another detected nickel atoms in its gaseous tail, an element typically released only when surface grains are heated to several hundred degrees Celsius, indicating strong solar heating despite the object's high velocity. But from the very get-go, 3I Atlas was anything but usual. Strange behavior and scientific findings. Since its discovery, the interstellar visitor 3I Atlas has exhibited a suite of strange behaviors that set it apart from typical solar system comets. In early August 2025, when it lay at a heliocentric distance of roughly 3.32 astronomical units, or about 3.32 times the Earth-Sun distance, the James Webb Space Telescope used its NIRSPEC instrument to record infrared spectra spanning wavelengths from 0.6 to 0.53 micrometers. The resulting spectral images revealed the coma, or the gas and dust envelope, of 3I Atlas to be dominated by carbon dioxide gas, with a mixing ratio of carbon dioxide to water measured at approximately 8:1, as noted earlier. But why does it matter? Well, this value is among the highest carbon dioxide to water ratios ever observed in a cometary coma, and it lies about 6.1 standard deviations above the trend established for long-period and Jupiter family comets. Such an extreme carbon dioxide-rich composition immediately raised questions. In typical solar system comets, water vapor tends to dominate the outgassing when the body is within a few astronomical units of the Sun. But in this case, carbon dioxide outgassing clearly overwhelmed water. One explanation proposed is that the nucleus of 3I Atlas may have an intrinsically high carbon dioxide content, perhaps formed in or preserved from a region of a protoplanetary disk near the carbon dioxide ice line, where temperatures fall low enough for carbon dioxide to freeze even as water remains volatile. Another possibility is that the body's surface has developed a crust or insulating layer through long exposure to cosmic rays during its interstellar wander, inhibiting solar heat penetration and suppressing water sublimation while allowing carbon dioxide, which sublimes at a lower threshold, to escape more freely. Complementary observations from the NASA SPHEREX mission detected a spherically symmetric carbon dioxide gas coma extending to a radius of at least 348,000 kilometers around the nucleus, with an estimated carbon dioxide production rate of roughly 69 kilograms per second. In contrast, the upper limits for water and carbon monoxide production rates were far lower. 3I Atlas's outgassing behavior is thus markedly different from standard comets. Spectroscopic characterization of the dust and surface has added further layers to the puzzle. Near-infrared spectra taken on 5 and 14 July 2025 with Gemini South and NASA's IRTF showed that the optical continuum of 3I Atlas is red-sloped in the visible and flattens in the near-infrared, a behavior that is consistent with a mix of organic-rich material and water ice grains of around 10 micrometers in size. The modeling suggests that around 30% of the coma material may be comprised of such water ice grains, a fraction that would be high for a typical comet, but consistent with an origin in a colder, more distant environment. Polarimetric measurements, though still limited, suggest the dust may be dominated by larger grains and has reflectivity properties that differ from those of most Jupiter family and Oort cloud comets, hinting at a surface crust or dust mantle evolved under unique conditions. Together, these chemical, dynamical, and physical oddities support the view that 3I Atlas may have formed in an extremely cold, carbon-rich environment, far beyond the typical regions where solar system comets originate. If the body was born around a star whose protoplanetary disk had a carbon dioxide ice line very far out, or if it spent eons exposed to interstellar radiation and cosmic rays that altered its surface, the resulting nucleus might carry a chemistry and structure quite unlike any seen before. If the parent system were a low metallicity star in the thick disk of the Milky Way, the original formation and subsequent evolution of 3I Atlas could date back many billions of years. But that's not all. Avi Loeb's hypothesis and conversation with Joe Rogan, the Baird Professor of Science at Harvard University and former chair of its Department of Astronomy, Avi Loeb, has long been one of the most polarizing voices in astrophysics. His interest in interstellar visitors began in 2017 with one Oumuamua, the first confirmed object from beyond the solar system to pass through ours. While most astronomers interpreted Oumuamua as an unusually shaped natural body, Loeb proposed that its non-gravitational acceleration and lack of a visible coma might instead indicate something artificial, perhaps a piece of alien technology propelled by sunlight. That debate has resurfaced 8 years later with the arrival of another mysterious visitor, 3I Atlas. On July 16, 2025, Loeb and two collaborators, Adam Hibbard of the Initiative for Interstellar Studies and Adam Crowell, a British science writer, published a short analytical paper on Archive titled "Is the Interstellar Object 3I Atlas Alien Technology?" The paper began by acknowledging that 3I Atlas's activity and appearance were consistent with a comet, but it then explored what Loeb described as a pedagogical thought experiment. They noted that the object's orbital inclination lies within 5 degrees of the ecliptic plane, the disk in which most of the planets orbit. The probability of such an alignment happening by chance, they calculated, was less than 0.005%. The paper speculated that if 3I Atlas were an engineered probe, its trajectory, crossing the paths of Venus, Mars, and Jupiter after perihelion, could represent an intentional course designed for planetary reconnaissance. Loeb emphasized that his analysis was not proof of an alien craft, but an argument for intellectual openness. Science, he wrote, must consider all possibilities until the data decisively rule them out. He pointed to the object's apparent non-gravitational acceleration, which, in his view, might be explained not only by outgassing, but also by other forces, such as radiation pressure acting on a thin structure, as he had once proposed for Oumuamua. If it's a sail, it could be designed to harness starlight, he remarked in interviews. These ideas quickly reached a mainstream audience through Loeb's appearance on the Joe Rogan Experience, one of the world's most watched podcasts, in late July 2025. During the 2-hour conversation, Rogan introduced the topic with characteristic curiosity. So, Professor, are we looking at another Oumuamua, something that could actually be a probe from another civilization? Loeb replied that while the data did not demand that interpretation, the odds of 2 interstellar objects in a row, both showing odd acceleration and alignment patterns, merited attention. He described 3I Atlas as a messenger, possibly ancient, from another technological culture, comparing the search for such relics to archaeology. But on an interstellar scale, Rogan pressed him on whether mainstream astronomers took the idea seriously. Loeb acknowledged that most of his colleagues favored natural explanations, but argued that ignoring the possibility of technology because it sounds extraordinary was unscientific. If you find a strange device on a beach, you don't assume it's a rock, he said on the show. Back in 2017, when Loeb first advanced similar ideas regarding Oumuamua, he faced criticism for what some researchers considered premature speculation. Now, the debate replayed almost identically, but on a larger scale, amplified by social media and Rogan's global audience. Articles appeared in outlets such as Live Science, The Guardian, Space.com, and Scientific American, examining Loeb's claims alongside responses from mission scientists and planetary astronomers. One Live Science headline in August 2025 summarized the mood, "Here we go again." Astronomer suggests new interstellar comet could be alien technology. NASA and the European Space Agency responded cautiously but firmly. In a September 2025 briefing, a NASA spokesperson reiterated that current observations of 3I Atlas show behavior consistent with known cometary processes. Instruments including JWST, the Very Large Telescope in Chile, and the Hubble Space Telescope had detected a well-defined dust tail and gas emissions typical of sublimating ices. The measured acceleration, they noted, could be explained by asymmetric outgassing, jets of carbon dioxide venting from the sunward hemisphere. Polarimetric data, meanwhile, matched expectations for natural dust grains rather than metal or composite materials. Astronomers such as Karen Meach of the University of Hawaii's Institute for Astronomy and Olivier Hainaut at the European Southern Observatory argued that 3I Atlas was a perfectly natural interstellar comet. Remarkable, yes, but not artificial. Meach pointed out that interstellar objects would likely display diverse chemistries and structures because they originate in alien planetary systems. The unusual carbon dioxide ratio tells us about where it formed, not who built it, she said in an August 2025 interview. Others noted that Loeb's estimated acceleration was far above the limits observed by JWST and ground-based astrometry, implying that his model relied on speculative assumptions rather than direct measurement. Still, even his critics concede that Loeb's provocations serve a purpose. By daring to treat interstellar objects as potential techno-signatures, he pushes the boundaries of what questions astronomy is willing to ask. The term techno-signature, used within the broader framework of the Search for Extraterrestrial Intelligence, or SETI, refers to any observable sign of technology not produced by humanity, from artificial satellites to industrial gases. Loeb's Galileo project, launched at Harvard in 2021, actively searches for such evidence using optical and radar data, and 3I Atlas naturally became one of its focal points in 2025. As the year advanced, telescopes continued to track the object's behavior. Around October 30th, 2025, at its perihelion distance of roughly 1.4 astronomical units, 3I Atlas brightened substantially but showed no unusual flares or controlled motion. Its outbound trajectory conformed closely to predictions. The European Space Operations Centre reported deviations from a purely gravitational path, but they were well within natural limits for a moderately active comet. Nonetheless, Loeb maintained that collecting as much data as possible remained essential. "We should not decide the verdict before the evidence is in," he told Rogan in a follow-up segment released in early October. He urged for an active investigation, suggesting that future missions might be designed to intercept similar interstellar visitors quickly. He framed this as part of a new discipline, interstellar archaeology, dedicated to examining objects that may be relics of other civilizations' technologies, whether natural or manufactured. For the wider scientific community, 3I Atlas became a real-time lesson in how evidence, speculation, and media intersect. On one side, professional astronomers pursued careful, peer-reviewed measurements of the object's chemistry, dynamics, and morphology. On the other hand, popular media transformed the story into a narrative about alien messengers and cosmic mysteries. Between these poles, public fascination flourished. Through it all, the consensus has remained that 3I Atlas is a natural interstellar comet formed in a distant cold region of another star system. Yet Loeb's hypothesis, amplified through the world's largest podcast, ensured that the discussion would not end with this object's departure. It highlighted a recurring tension in modern science, the balance between skepticism and imagination, between what is proven and what might yet be possible. Whether 3I Atlas is ultimately remembered as a curious comet or as the first hint of alien technology, its passage through the solar system will be remembered as a moment when data, dialogue, and daring speculation converged, and when humanity once again looked to the stars and wondered if something out there was, in fact, looking back. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.